Let's do number 2 on the Unit 6 Progress Check Free Response Questions, Part A. Okay, they gave us a couple things. They gave us this graph. This graph has, what is the derivative of f prime? They said so, and they told us the areas. We can read all this information here. They told us this little handy piece of information. So that deals with f prime. Now they also told us some stuff about g, and g is x squared minus 1. Okay, so full disclosure, I had already begun this video and had some explanations that were a little subpar. So I already have some work showing, and I'm going to just deal with it. So as we move forward, you're going to be seeing the work that I had just done. All right, find the value of 0 to 9 f prime of x dx, and this is going to be, let me tell you what it's not. Okay, let's just go ahead and start with that. The integral from 0 to 9 of f prime of x dx looks like we would do, well, the antiderivative of the derivative from 0 to 9, which gives me f of 9 minus f of 0, and then you're stuck, because you're like, I don't know what f of 9 is, I don't know what f of 0 is. At this point, given what we know, or the way we're at least wrapping our mind around it right now, we don't have enough information. We eventually will, but at the moment we sort of don't, kind of. So really, this is not the most efficient way to do it. I have a much better way. Let's do the accumulated area. Just the accumulated area of my graph. That's what an integral is anyway. So that, losing track of where my papers are. Here we go. That's the bottom one. That's it. There's my answer right there. And if you're wondering where those numbers came from, just look at the graph. As we go from 0 to 9 on the x-axis, we are basically going to be finding the accumulated area, 12, negative 10, because that part's below the x-axis, positive 5, and negative 1, and it ends up with 6. Okay, that was part A. All right, here's part B. Given that f of 6 equals 7, that's good to know. All right, so we kind of have somewhat of a starting value, not at 0 necessarily, but that's okay. Write an expression for f of x that involves an integral. Let's just stop right there and we'll deal with that. So if I'm going to write an expression for f of x that involves an integral, then I'm going to need to know my starting place, and I'm going to need to know how much value of the function I have accumulated since 6. Okay, let me say that one more time because I think it's kind of important. And as I say it, I'm actually going to point to the answer. In order to write an expression for f of x, I need to know my starting point, and I also need to know how much function I have accumulated from 6 to wherever I'm going. And notice that these are t's, they're not x's. Let's not overdo that whole x thing here because we have the x as an input of our function. Okay, now that is part of part B. We have not finished part B. So we're going to use this expression to find the absolute minimum value of f and the absolute maximum value of f on the closed interval from 0 to 9, and we're going to justify our answers. Okay, that sounds like we're looking for extreme values. Okay, extreme values occur where the derivative equals 0. Pause that thought right there. Extreme values occur where the derivative equals 0. So 3, 6, and 8. And they also occur at the endpoints of the interval. So we will also deal with 0 and 9. Okay? So we're going to have to evaluate the value of the function, which we can do now. We actually could have done part A differently given this knowledge, but we weren't quite there yet in the process. So I'm going to make a table, and hopefully this will start making a little more sense. So here we go. Move these papers out of the way. My x value and my f of x value. And I'm going to test every endpoint of an interval, 0 and 9, and everywhere that the function equals 0, which is 3, 6, 8, and actually 9. I didn't mention that one earlier, but that does also apply. So 0, 3, 6, 8, and 9. And we are going to figure this out. Actually, let's back up and do one more step on this. F of 6 equals 7. I think that's good to know, and they'll probably be looking for that more specific answer rather than our just f of 6, because they told us what it was. F of t, dt. Okay. So this is going to be, well, f of 0, which would be 7, plus the integral from 6 to 0 of f prime of t dt. And if you're like, what in the world is he even writing? What does that even mean? It's all zoomed out. Okay, don't panic, don't panic. We're going to just keep going with this idea. 7 plus the integral from 6 to 3 f prime of t dt. 7 plus the integral from 6 to 6. You can see where this one's going. F prime of t dt. 7 plus the integral from 6 to 8 of f prime of t dt. 7 plus the integral from 6 to 9 of f prime of t dt. And let's figure these out. Now we're going to find the maximum and the minimum. I'm going to go for the easy one first. This is really 7, looks like not equal to, but it is equal to 7 plus 0, which of course is 7. Okay? All right, let's just move forward because I feel like it. So this is going to be 7 plus something. Okay, we're going to go from 6 to 8, and this is really a matter of accumulated area. So as I go from 6 to 8, I've accumulated 5 more units of area. So 7 plus 5, which of course gives me 12. Okay, looking for the highest, looking for the lowest. Okay, well this is 7 plus, going from 6 to 9 gives me, well, 5. And takes away 1, so you could say it's plus 5 and minus 1. Treat it however you want, but that would be 11. Okay, number 3, 7 plus. Okay, now things get a little bit tricky. And normally I say that what's below the x-axis is negative. It really depends on the direction you're going. So as we go from 6 to 3, we are backing up. And that means that instead of me saying, oh, look, this is negative 10, it's actually positive 10 because we're going backwards. You can write this a different way. You could say 7 minus 3 to 6, but I just chose not to. But anyway, this ends up being 10, so that one's 17. And then as we go this way, we'll have 7 plus the 10 that we just crossed. So 7 plus 10 minus 12 because we're going backwards now. So what's above the x-axis is negative. So minus 12, and that is going to give me 17 minus 12, which is going to give me 5. Okay, fantastic. So we will have a maximum value and a minimum value, and we have already considered all the points that we need to consider. So when it said, let's read the problem again. Use the expression to find the absolute minimum value of f and the maximum value of f in a closed interval. Justify your answers. This work is somewhat of a justification. In a minute, though, I am going to just articulate what happened. But here goes. The absolute maximum value of f on the interval from 0 to 9 is, okay, it's not 3. It's 17. I'm going to be really specific. I'm going to say f of 3, which is 17. And the absolute max, oops, I just said max. We'll say it again. Absolute minimum value is the lowest one, which is 5. So f of 0, which is 5. Okay. So again, let's do a little more justification. We considered where not t, sorry, wrong variable. I don't know what t is. Well, it's this thing you drink. But anyway, where f prime of x equals 0, and we also considered the endpoints of the interval. This is not a mean value theorem, an extreme value theorem issue. Okay, there is part B. Let's move on to part C. Things get a little fun on part C. Actually, things get pretty easy on part C. Part C, I won't even show you the paper because it's so straightforward. The integral of g of x dx, which means we want the integral of x squared minus 1 dx, which is basically an antiderivative. There we go, minus x and then plus c. That's all they're looking for, that's it. And then we get to part D, which asks us this. And now things get a little bit tricky. We're going to have to do some U-substitution with definite integration. Okay, they ask for this. Now, if you're panicking and you're like, well, wait a minute, I don't know what f prime is. Don't panic if you don't know the equation. Let's just go with what we do know. We do know g, and that is the integral from 2 to 3 of x f prime of x squared minus 1 dx. And at this point, I'm feeling some U-substitution. There's clearly a function inside another function, so let's just pull out a red pen and start doing some U-substitution. U is x squared minus 1. Du is 2x dx. I don't want 2x dx, I want 1x, so x dx. And that's equal to 1/2 du, okay? So the next step is going to look like this. I really want 1/2, we'll put it in front just for fun, integral of f prime of u du, but let's be careful. That's not a 2, that's not a 3 anymore. We have redefined it. So 2 squared minus 1, before minus 1, that would be a 3. And 3 squared minus 1, that would be an 8. Now this again is calculator inactive, but that is totally okay. We can do this. Actually, we won't need calculators at all for this. It's going to be kind of fun. Just in case you're wondering where that came from, and this is for the sake of explanation, this is 3 squared minus 1, and this was, oops, this was 2 squared minus 1. Sorry about that. And this was 3 squared minus 1, just in case you need to see that. All right, let's keep going. The accumulated area from 3 to 8, that's what this is really saying. And so the accumulated area from 3 to 8 is negative 10 plus 5. Okay, that's pretty easy. So 1/2 negative 10 plus 5, which is negative 5 halves. That's it. There's another way of doing it where you do the fundamental theorem of calculus, and you would have to know the value of the function at 3 and the value of the function at 8, which you actually already found. But this, I think, is easier. That's more of an accumulated area issue.